Speed doesn't exist at a single moment. Or does it? When you drive at 60 kilometers per hour, that number describes something real. But if you freeze time, a single instant, there is no motion, no distance, no time passing. So how can speed exist at all? This is the question the derivative answers. We start with a curve, any curve. Let's say it describes the position of something moving. Pick 2 points on the curve. Draw a line through them. This line is called a secant. Its slope tells you the average rate of change between those 2 points. Now move the second point closer to the first. The secant shifts. Its slope changes. Closer still, and closer. Watch what happens as the gap shrinks towards zero. The secant approaches a limit. At the limit, it becomes a tangent, touching the curve at exactly 1 point. That tangent slope is the derivative. It is the instantaneous rate of change, the slope that exists at a single moment. This is what calculus invented, a way to take the limit of a process, not stopping at a small gap, asking what happens when the gap becomes nothing. The derivative of a function f at a point x is written f prime of x. It is defined as the limit of the difference quotient as h approaches 0. F of x plus h minus f of x divided by h as h goes to 0. Let's see it with a concrete example. Take f of x equals x squared. The difference quotient becomes x plus h all squared minus x squared divided by h. Expand the numerator. Squared plus 2xh plus h squared minus x squared. The x squareds cancel. We are left with 2xh plus h squared divided by h. Factor out h times the quantity 2x plus h divided by h. Cancel the h. 2x plus h. Now take the limit as h approaches 0. The hey disappears. The derivative of x squared is 2x. At any point on the curve, the slope is exactly twice the x value. At x equals 1, the slope is 2. At x equals 3, the slope is 6. The derivative is not an approximation. It is the exact slope at every single point. This is what makes calculus powerful. Not that it gets close to the answer, but that it reaches it. The slope that moves precisely defined everywhere at once.